Alright, in this next section, it's going to cover simplify trig expression to eliminate fraction. So when it comes to eliminate fraction, there's a part where we cover, such as from Algebra 2, and then you will see it again in this class, pre-cal, is that we're going to talk about the conjugate. So the conjugate ties into the difference of squares. So what it means that this is based in your denominator. If you have a term, x plus a, to multiply by the conjugate, you will multiply by x minus a. If in your denominator you have x minus b, then the conjugate would be x plus b. So if you look closely at the patterns, the x and a's are the same, including the x and the b, but the only difference is the operation. So if you start with plus, you're going to multiply by the minus. If you start with the minus, you're going to multiply by the plus. And you see why we're going to multiply by the conjugate. So in our first example, we have sine x over cosecant x minus cotangent x. So what we're going to do is, we're going to look at the denominator. We actually have a binomial term, two functions in the denominator. We're going to multiply by the conjugate. So the conjugate is the opposite sign of your denominator. So in the original example, we have cosecant x minus cotangent x. So the conjugate will be cosecant x plus cotangent x on the top and on the bottom. Alright, so the reason we're going to do that, and you already seen it in the last video, is when you multiply, the middle terms will cancel out, which I will show you. Alright, so we're going to FOIL. So cosecant x times cosecant x will be cosecant square x. Cosecant x times positive cotangent x will be plus cosecant x cotangent x, and then minus cotangent x times cosecant x will be minus cotangent x cosecant x, and then minus cotangent x times positive cotangent x will be minus cotangent positive square x. Now, be mindful that I have little space, so I'm going to rewrite it. Well, I don't have to. So here and here, you see how it has cosecant x and cotangent x, and it's multiplying cotangent x and cosecant x. Even if they're multiplying, I can switch the two functions to be in the same order of the two. So I can rewrite this as minus cosecant x cotangent x. So you see how this is the same order as the first one. Now if you take a closer look, you see how this is a minus, so this is a negative. The first one was a positive because it had that plus. So if I were to combine these two would cancel out, and the only thing I have left is cosecant square x minus cotangent square x. So on the top is going to be sine x times cosecant x plus cotangent x. So I'm going to write that. I'm not going to distribute, I'm just going to keep it as separate. So sine x parenthesis cosecant x plus cotangent x over cosecant square x minus cotangent square x. Alright, so after that, what I'm going to do is cosecant square x minus cotangent square x. I'm not going to mess with that for now, but what I'm going to do is going to mess with the top part. So here's the reason why I didn't want to distribute in the first place. What I'm going to do it here with cosecant x and cotangent x, I'm going to convert it into terms of sine and cosine, meaning convert it and using the reciprocal and the quotient identity. So I'm going to write it here below. So sine x. Now cosecant x, I'm going to use the reciprocal identity, which is 1 over sine x, and then plus. Now for the cotangent x, I'm going to use the quotient identity, which is cosine of x over sine of x in parentheses, and then the denominator stays the same. Alright, so I'm gonna move right here since I have a little space. Alright, now what I'm gonna do is distribute the sine x to everything in the parenthesis. So when I distribute, sine x times 1 will be just sine x over sine x plus, then I distribute this sine x to the numerator, so on the top will be sine x cosine x over sine x, and then my denominator stays the same. So cosecant square x minus cotangent square x. Alright, so since I'm running out of room, I'm gonna erase and make more room. Alright, now I have some more room to continue with this example. Alright, so I'm going to simplify the numerator. In my numerator, sine x divided by sine x will be simply 1 plus sine x cosine x divided by sine x. So here I can divide the sine x because there's 1 on the top and 1 on the bottom. Again, I can do that because on the numerator it's multiplying. So after 1 plus, the only thing that is left is cosine of x. And then on the denominator, it's still cosecant square x minus cotangent square x. Now here, I'm going to take a closer look at it because they're both square. Now if I go back to my identities, which I could probably use that's very close to cosecant square x and minus cotangent square x is the Pythagorean identity. So let's write the Pythagorean identity here. So the Pythagorean identity, the one that used cosecant square x and cotangent square x, would be cotangent square x plus 1 equal cosecant square x. Now it's the same thing if you were to write it as cotangent square theta plus 1 equal cosecant square theta. So it's the same thing, but one use theta and one use x. It's the same function, same operation. Now let's talk about the first one. So if I were to do cotangent square x plus 1 equal cosecant square x. Now if I look at this one, you see how cosecant square x and cotangent square x are together. So what I need to do is get cotangent square x and cosecant square x to be the same side. So what I'm going to do is I'm going to subtract cotangent square x on the left, subtract cotangent square x on the right side. So on my left side of the equal sign will be 1. On my right side will be cosecant square x minus cotangent square x. You see how this is the same as that? So what I'm going to do is switch out cosecant square x minus cotangent square x with 1, because cosecant square x minus cotangent square x is equal to 1. So the numerator stays the same, so 1 plus cosine of x over 1, and then 1 plus cosine of x divided by 1 will be simply 1 plus cosine of x. And that would be our final answer, because there's nothing you can do to simplify. I don't need to apply any identities at all, so that would be my final answer. So 1 plus cosine of x. And to review, I applied the concept of what we did in the previous section, rewrite using sine and cosine. So I wrote some of them, especially the numerator, in terms of sine and cosine to simplify. And then I also applied the reciprocal and the quotient identities while simplifying. And then near the end, I applied the Pythagorean identity for cotangent square x plus 1 equals cosecant square x. Sometimes you have to take a closer look. There is a relationship between cosecant square x and cotangent square x, especially when I said square on both of them. So since I know there's a relationship, that means that there is a Pythagorean identity where I got it on both sides and it equals to 1. Simplify to 1 plus cosine of x over 1, and then the final answer is 1 plus cosine of x. Alright, here we have a second example. Again, we're trying to simplify to eliminate fractions. Now, if you have a fraction and say you have a denominator of 1 plus sine x, you can multiply it by the conjugate. So by the conjugate is going to be the opposite sign. So I'm going to multiply top and bottom by 1 minus sine x. So that's all I did. Now if we were to FOIL, I'm going to write right here 1 plus sine x times 1 minus sine x. So we're going to FOIL 1 times 1 is 1. 1 times minus sine x will be minus sine x. Sine x times positive 1 will be plus sine x. And then sine x times minus sine x will be minus sine square x. Alright, so just like in the previous example, you see how the middle terms right here and right here, one is negative, one is positive. I combine like terms, they're going to cancel out, and then we're simply going to have 1 minus sine square of x. So when that happens and we multiply, we're going to have cotangent of x times 1 minus sine of x, that's from the numerator, over 1 minus sine square of x. So far that's what we have. Now looking at this, analyzing, is there anything else I can do before I work on the numerator? Yes, I can. I see I have a 1 and a sine square x, it's minus, so I'm going to use the Pythagorean identity. So I'm going to switch out the 1 minus sine square x. You can substitute, because 1 minus sine square x equals to another trig function. So the numerator will stay the same. So cotangent of x times 1 minus sine of x over, and then now instead of 1 minus sine square of x, it will be cosine square of x. Again, I use the Pythagorean identity. Alright, so after that, and I see that nothing else I can do, so what I'm going to do is I'm going to distribute cotangent of x to everything of the numerator. So cotangent of x times 1 would be simply cotangent of x, and then minus cotangent of x times sine of x will be sine of x, cotangent of x, everything over cosine square of x. Alright, looking at that, there's nothing else I can simplify. So what I'm going to do is apply some identities. Now here, cotangent of x, if I were to convert them in terms of sine and cosine, I'll use the quotient identity. Same thing here with the cotangent of x. Now sine of x, I'm just going to leave it be because it's already in sine. So again, I'm only applying the quotient identity for cotangent of x. So the quotient identity for cotangent of x will be cosine of x over sine of x minus sine of x times another quotient identity for cotangent of x, so cosine of x over sine of x and the whole thing over cosine square of x. Alright, so I got everything in terms of sine and cosine. Next, I'm going to distribute this sine of x to that cosine of x to the numerator only. So on the top will be cosine of x over sine of x minus sine of x cosine of x over sine of x over cosine square of x. So to review, this is cosine of x over sine of x minus sine of x times cosine of x over sine of x, the whole thing over cosine square of x. So we're going to keep simplifying because again the name of this section is simplify to eliminate fraction. So what I'm going to do is I'm going to erase to make more room. Alright, now taking a closer look, see if I can simplify before I can work out with fraction. Can't simplify here, but over here I can, because I have a sin x on the numerator and a sin x on the denominator, and it's multiplying on the top. I can simplify this fraction. So the rest will stay the same. So cosine of x over sine of x minus. Now since we're working with fraction, I'm going to keep it in the form of a fraction. So when I simplify this, the sine of x will divide, and I'm going to have cosine of x over 1. Now, again, the reason I'm keeping it as a fraction is because we will continue working with fractions. So you would simplify it at the very end. So what I mean by you're going to simplify it at the very end. If you have something like this, cosine of x over 1, you have to simplify it. Again, I would ask you, what's cosine of x divided by 1? You should be saying cosine of x, and that's the final answer. In the event you have something like this. But I'm going to keep it as a fraction because we're still not done. Alright, so next, since we have multiple fractions on the top, and we have cosine square x on the bottom, what I'm going to do is I'm going to convert cosine square of x into a fraction. And then I'm going to rewrite it as a division. So the numerator divided by the denominator. So cosine of x over sine of x minus cosine of x over 1. Now the whole thing I'm going to put in parentheses because they're from the numerator, times, no, not times, divided by the denominator. So cosine square of x over 1. Now, since we're dividing with fractions, let's change it into a multiplication. So cosine of x over sine of x minus cosine of x over 1 times 1 over cosine square of x. Alright, so now we're going to be multiplying with fraction. This fraction right here is going to multiply to everything inside the parenthesis. So when that happens, what we're going to have is 1 cosine square of x times cosine of x sine of x will be, again, we're multiplying fractions, so we multiply straight across. Cosine of x times 1 will be simply cosine of x. Cosine of x times cosine square of x will be sine of x cosine square of x. There's our first fraction. Now it's minus cosine of x. Again, we're multiplying fractions, so straight across. So cosine of x times 1 will be cosine of x over 1 times cosine square of x will be cosine square of x. Alright, so that's what we have so far. Next, I'm going to erase to make some more room. Okay, to review, cosine of x over sine of x times cosine of x minus cosine of x over cosine square of x. Oh, Made a little mishap. This should be a square. Alright, so when we're simplifying, I noticed that I have a cosine of x in the numerator and a cosine square of x in the denominator in this fraction, and then I have the same thing over here. So since there's a common factor in the numerator and denominator, I'm going to simplify by dividing top and bottom into 1. So cosine of x and then cosine of x here, when I divide, the only thing I have left is 1 on the top, sine of x. Now the cosine square of x did not go away, did not become 1. When there was 2 cosine of x, cosine square of x, that means there were 2 of them. So one of them became 1, and then I have left cosine of x in the denominator. Same thing here. I'm going to divide cosine of x, but since on the denominator is cosine, it was cosine square of x, that means there were 2 of them in the denominator. When I divide, only one of them from the denominator became 1. So I'm going to have just 1 over cosine of x on the second fraction. Alright, next, since this is multiplying, there's nothing I can do to apply a identity on sine of x times cosine of x. What I'm doing is I'm going to split it as 2 fractions multiplying to each other, because as you can see in the denominator, sine of x times cosine of x, that's what you can see they're multiplying. So our first fraction is 1 over sine of x times 1 over cosine of x minus 1 over cosine of x. Now we have this 3 fraction, but to go back to the title, simplify to eliminate fraction. So what we're going to do is we're going to apply some identities. The only identity we can apply is the reciprocal identity because it has 1 on the top. So 1 over sine of x will be cosecant of x, and then 1 over cosine of x will be secant of x. Now you can put parentheses if you like when they're multiplying, and then 1 over cosine of x will be also secant of x. Now I can still simplify this because in the first part and in the second part they both have secant of x. So what I'm going to do is I'm going to factor out the common factor. So our common factor will be secant of x, parenthesis. When I factor out secant of x from here, the only thing I have left is cosecant of x, and then minus, and then when I factor out secant of x, then the only thing I have left is 1. Alright, so that's all I can do, nothing else I can simplify, no other identities, and we don't have fraction. So this will be our final answer, secant of x times cosecant of x minus 1. So just to review, we implement numerous identities, reciprocal, the quotient, and the Pythagorean identities. And then we kept working with fraction, combined with fraction by adding, subtracting, multiplying, and dividing. Even though we were working with fraction, the goal of it was to simplify to eliminate fraction, meaning that not to have a fraction as the answer. Here, we're going to keep it as secant of x times cosecant of x minus 1 instead of leaving it in terms of sine and cosine, because they're all in fractions. And then the title of this section is to eliminate fractions. So we implement the reciprocal identities so that we don't have fraction in our final answer.